Thank you very much, Asi, for that interesting presentation on how we will eat in the future when we can manipulate it even more. It's now my pleasure and honor to invite Pat Brown, to speak about his visions for the future of food. He's the founder and CEO of Impossible Foods, but before that he had a distinguished academic career. He was a biochemist at Stanford, where he transformed genetic research, global genetic research of course, and also cancer research. And he became a member of the prestigious National Academy of Sciences before he switched to influence reality more by making us all more vegetarian in the way we eat, the way he had already been for 30, 40 years or something, 30 years. Looking at you, it can't be 40 years. Please welcome Pat.
Just a second here. Well, first of all, thank you very much for having me here. Really, I'm honored to be invited and already enjoying the meeting, so thank you all. I need, can you switch to my? Sorry, just a moment. While I'm waiting for this to
there you go.
Okay, thank you. Oops. Aha, okay, great, thanks. I was, for many years, a professor in the medical school at Stanford, and it was, for me, basically my dream job, the greatest job in the world, because essentially my job description was, or my responsibilities were to invent and discover things, and that was pretty much it, with no further restrictions than that. And so I could hardly have imagined ever wanting to leave that job, but about 6 years ago when I had a sabbatical, I wanted to pick and work on the most important problem in the world that I could identify and have an influence on. And I decided that it was to replace the world's most destructive technology, which I'll tell you about in a second, and that it was urgent and important enough that since nobody else seemed to be taking it as seriously as it should be taken, that I had to quit my job and do something I never imagined I'd do, which is start a company to take on the problem. So I'll tell you quickly, I'll start out by telling you why this is important, and then I'll spend some time talking about how we're approaching the problem and where we've gotten with it. So, in case it's not obvious, the world's most destructive technology is the use of animals as a system for producing food. And although it's actually amazing how few people really appreciate the magnitude of the problem, it's not as if it hasn't been studied by serious scientists. For example, in 2010, the UN Environmental Program published a study that looked at the environmental impacts of all the major industrial sectors. And what they concluded, and that's this kind of bar graph on the right, and look at the orange part of it, is that by a huge margin, the production of food from animals is the most destructive economic sector. even though its contribution to the global economy is relatively small. And there are many reasons, there are many ways in which it's destructive, and I'll just give a few of the major ones. One is its greenhouse gas impact. So not even taking into account the opportunity cost of its huge land footprint, which I'll talk to you about in a second, just the net emissions of greenhouse gases from the animal farming industry are greater than the total emissions of every car, bus, truck, train, plane, rocket ship on Earth combined. Or to look at it another way, 60% higher than the greenhouse gas emissions that you would get if you took every oil field in the Middle East and set it on fire and left it burning. Animal farming emits 60% more greenhouse gases than that would. Okay. So to put it bluntly, there's really no conceivable way we're going to meet the goals that were set at Paris last December without a huge reduction in this industry. Secondly, water impact. So I think that, again, everybody is recognizing now how limited our supply of fresh water is and how, in some cases, critically overtaxed it is, leading to conflicts around the world. Animal farming, according to the UN Food and Agriculture Organization, consumes and pollutes by a large margin more water than any other industry. The amount of water that's currently consumed every single day by this industry is a cubic meter of water, 1,000 liters of water for every person on Earth, or enough to fill San Francisco Bay every day. And the land use impact is actually the really where the biggest threat comes from. So people talk about urbanization, you know, as a threat to natural ecosystems. But urbanization is trivial in terms of its impact by comparison. So this, according to a publication a couple of years ago that used satellite imaging to calculate the total areas of all the cities in the world greater than a square kilometer in size. That's it, that little dotted line, that little dotted circle there. It's about 0.5% of Earth's land area. By comparison, the area occupied by animal farming in 2011, according to the International Livestock Research Institute, whose motto is Better Lives Through Livestock, is 45% of every square kilometer of land on Earth in 2011. That's the area of North America, South America, Europe, Australia, Indonesia combined. Currently in use, raising animals for food. Basically leaving an area equivalent to part of Asia and Africa to support all cities, industries, roads, infrastructure, non-animal agriculture, and wildlife habitat. And the threat to wildlife habitat actually, according to, a lot of recent publications by environmental scientists. And again, actually, if anyone here wants references for the statements that I'm making here, there's a lot of rigorous science behind it. Email me, and I'll send you more articles than you probably want to read. But according to a lot of environmental scientists, the biggest threat right now to basically the survival and quality of life of the human species is the destruction of wildlife habitat and the ecosystem services that they provide that we just take for granted. This is just one measure of this. So Mr. Trigg actually mentioned earlier about this World Wildlife Fund study that was looking at just the impact, basically, of humanity on wildlife. This is actually from 2 years ago. It just looks worse if you look at the 2016 version. But basically what they do is every few years they do a census of thousands of animal species around the world. Okay, they attempt to count the number of individual living members of each species that sample kind of the diversity of life on Earth. And what they published in 2014 is that the total number of living wild animals on Earth, that's mammals, birds, reptiles, amphibians, fish, kind of across all those categories, was less than half what it had been 40 years ago. We've reduced by a factor of 2 the number of living wild animals on Earth in the past 40 years. And by far the biggest driver is the use of animals for food. And this is another figure from that study. So the blue sector in this kind of, and let me just qualify this by saying, obviously, when you attempt to kind of quantitate these sorts of impacts, there are assumptions that go into it. This is not like measured with precise caliper. But the blue sector here is overexploitation, basically hunting and fishing. The red and the green are habitat destruction and degradation, which are overwhelmingly driven by the expansion of animal agriculture. Okay, so these are the causes of that meltdown in wildlife populations. And it's not just that, you might say, well, it's kind of sad that we won't have giraffes anymore, but it's not, yes, that is sad, but that's not the problem. The problem is that these species are responsible for the stability of the ecosystems that we depend on for all sorts of things, not just natural beauty. Okay. And it's completely unnecessary from a purely nutritional point of view, because by the plant crops that were harvested this year, in fact, just the 4 major staple crops harvested this year, contain more proteins, more protein, more calories, and more of every essential amino acid than are required for optimal nutrition, not just of today's population, but of the 9 billion people we expect to be sharing the planet with in 2050. That's this year's harvest of just 4 plant crops. And if you, by any number of scenarios, you could meet all the protein and calorie needs of the world's population in 2050 with about 2% of Earth's land area. That's about the area of India. So not North America, South America, Australia, and Europe combined, India. Here's another way of looking at it. This is the area of the United States. About 49% of the area of the continental United States, according to the US Department of Agriculture, is actively in use raising animals for food in the US. About half of the area of the US. This is the area that would be required to replace all the protein in the fish, meat, and dairy that are expected to be consumed in 2050 by the 9 billion people in 2050. It's a rate of consumption that's actually about 60% higher than today's consumption of those animal-derived foods. All the protein in those foods in 2050 could be supplied just using a single crop and a single protein in that crop. And I can explain why I chose it if you have questions. Using a land area that's only about half of what we're using today just to produce for the US population. That could feed the world in 2050. Okay, so in principle, we've kind of, the problem seems pretty easy, right? I mean, it doesn't even need to be a problem. But it's not so easy, basically because people don't want to live on corn and soybeans. They want meat. And so that's the dilemma. How do you solve this horrible environmental problem and reconcile it with basically the insatiable demand of the world's population for these foods, which is not going to go away, and it can't be regulated away. Governments are not going to solve this problem, particularly governments run by angry toddlers. So we have to find another solution. And actually, this guy had the right idea. The problem isn't that people love meat. The problem is how we produce it. And how we produce it today is using animals, which from a food production standpoint is just an ancient, incredibly inefficient, and unsustainable technology that we've used for pretty much since the beginning of human civilization to transform plants into meat and fish and dairy foods. It's barely improved. It's incrementally improved over thousands of years. But it's fundamentally unimprovable beyond strict limits set by physiology. But it's unimprovable, but it's replaceable. And in fact, I think it's a sitting duck for disruptive technology, which is basically when I started viewing it this way, that's when I realized that I had to get into this. And so the challenge for us was we just need to invent a better and more sustainable way to transform plants into all the foods that we get today from animals. And it has to be not just more efficient and sustainable. That's easy. We don't need new technology to do that. We just need to switch to consuming plant-derived foods. It can't just be more efficient and sustainable. The fundamental challenge is the foods that we produce have to be uncompromisingly delicious and affordable. People are not going to compromise on the pleasure they get from eating these foods, and that means that if we're really going to solve this problem, we have to produce foods that deliver all those same sensory pleasures, same nutrition or better, and so forth. If we can do that, then no regulation, no coercion of any kind is required. The awesome power of the market will take care of the rest. Just create products that outcompete, and you can replace the existing technology. And I knew that this was doable from a scientific point of view, but it's a very hard problem. So about 5 years ago, when I started this, I raised money for the project and founded this company, Impossible Foods, with the mission of completely replacing animals in the global food system by creating uncompromisingly delicious, affordable, healthy, and sustainable meat, fish, and dairy foods directly from simple, natural, plant-derived ingredients. And I started it, because it was such a hard problem, by putting together this amazing science team. Really, I've worked with brilliant scientists for my whole career, and this is as brilliant a group of scientists I've ever worked with, not just brilliant, but mission-driven to take on this challenge. And I'm not going to be able to go in deep detail, although I'd be happy to, but I just don't have the time. I'll just summarize sort of the general way that we've approached the problem. And we approached the problem basically just the way I would have approached the problem in sort of the biomedical sciences. First, we have to start by having a deep understanding of, in molecular terms, of the foods that we intend to replace. So that means that we need to understand in molecular terms what are the characteristics, what are the sort of molecular characteristics that give, for example, meat its textural properties, its mouthfeel, its aroma, its cooking behavior, its flavor, and so forth. Understand that well enough in molecular terms that we can then search for the necessary ingredients from sustainable plant sources to deliver that same experience. Okay, that's part one, just reverse engineering, you can call it. A second part, really important, is to start with a blank slate and say, okay, let's it doesn't have to be from the widely grown crops now, but from plants that are scalable, widely geographically adapted, could be major plant crops. Search them all for proteins and other components that can enable us to reproduce those molecular characteristics. Identify proteins that satisfy those properties, satisfy nutritional properties, and so forth. We need to have a deep understanding of the biochemistry of flavor. I'll talk about that in a second. And then we need to understand how to take the proteins and ingredients that we get from plants, which we can't just sort of serve up in a pile on a plate, and turn them into materials that deliver the sensory pleasures that consumers demand from these foods. And all of those are hard scientific problems. I think I'll forget about walking around. Okay, and I'll just use for one example, I'll talk about something that I think is one of the core problems that we need to address. And this seems like a very obvious question. Obviously, it mattered a lot to us. What is it, in biochemical terms, that makes meat unlike any other food? So that if I blindfolded you and gave you something that was a meat, doesn't even matter what animal it comes from, you'd recognize it as meat and not something that came from plants, from its flavor. It turned out, so we looked into this, and it turned out that the answer could have been incredibly complicated, and it is complicated in its details, but 90% of the answer is really, really simple, and that is this molecule heme, which is the red iron-containing molecule that gives your blood its ability to carry oxygen. It gives muscle tissue the ability to bind and store oxygen. That's in muscle tissue, it's a protein called myoglobin that binds and stores oxygen. So if you suddenly have to run before your heart starts beating fast enough, you have an oxygen reservoir there. And it's this little molecule in the middle there. Okay, so heme is super abundant in all the animal tissues that we call meat. But it's actually found in every living organism on Earth. It's an essential molecule for life. It's found in bacteria and fungi and plants and so forth. But generally much lower concentrations. That's why they're not red or pink. But it's there. And the way that it works in a sort of overly simplified terms is this. So if I were to take a broth of the basic biomolecules that are found in every living cell, that would be amino acids, simple sugars, fatty acids, other organic acids, nucleotides, vitamins, and so forth. Okay, just cell juice, and put it and make a broth out of that and cook it. It would smell and taste a little bit savory, kind of like weak miso soup, but nothing to write home about, and certainly not like meat. But if you simply add heme to that mixture, you get instead of those very mild and relatively simple savory flavors and aromas, you get an explosion of cooking chemistry catalyzed by heme, which is one of the best biological catalysts on Earth, that transforms those simple nutrients into hundreds, actually thousands of novel, flavorful, and fragrant molecules that are the unmistakable flavor and fragrance of meat. Okay. Amazingly, that had never been discovered before, and that meant that we could patent it. It's a company. What do you do? So now, as I said, every living cell is able to produce heme, and that includes yeast. So yeast have the complete set of enzymes to produce heme. We use genetics to start with a widely grown yeast strain, quite similar to one of the strains that's used in producing Belgian beer, to amplify its ability to produce large amounts of heme. And as a result, instead of the little white colonies like the one up in the middle there, are on a Petri dish. You can see our little yeast colonies are bright red. So they enable us to produce heme in commercial quantities at prices that are compatible with our goals. Okay, so that's the science. Now, we built a technology platform that was agnostic as to the particular products. We needed to understand meat across the board. We're also working on fish. I won't talk about that, and dairy foods. But we decided for our first product to make something that basically is functional equivalent of raw ground beef. Because in the US, this is the single largest meat category. About half of all the beef sold in the US is sold as ground beef, which meant that if we could produce a competitive product that really delivered on flavor and nutrition and the things that consumers value, it would be hugely disruptive to the incumbent industry, which is our goal. So this is to illustrate a point that we made the product we made has to deliver not just on flavor and fragrance and texture and juiciness, but even on the way it cooks and the way it looks and be able to be cooked, served rare or medium rare or well done. If you ask consumers to compromise on any of the things that they care about, you're just putting yourself in a non-competitive position. So there was a bunch of scientific problems to be solved there. Once we've solved the scientific issues, and of course we're still working on this because unlike the cow, we can get better all the time. And we started working with basically these brilliant chefs who were amazingly receptive to this. They welcomed it, in fact. First of all of these guys, even though they're people who serve meat, I mean, Dave Chang is like the meat king of New York City. They recognize its environmental impact. And so having something that can deliver the same culinary properties without the destructive impact is welcome. Plus, it's interesting to them. So we've worked with the chefs. In fact, we launched a few months ago in a restaurant that's only about a mile from here. I encourage you to go there and for lunch and try our burger and decide for yourself whether it has any potential. But I can tell you that since we launched, basically, they've been packed every single day, and essentially everyone orders the burger at this restaurant, which has other things on the menu, but nobody orders them. Okay. And we've also launched in San Francisco and LA, and it's the exact same phenomenon in restaurants that are, by and large, run by people who are extremely well known for their meat. One of them is a guy named Chris Cosentino, who runs a pig-based restaurant where he serves every single morsel of the pig. He's very proud of it. He's actually a wonderful guy, but it's like the meat capital of San Francisco. But again, he decided to serve our product, and everybody orders it. At lunch, they can serve 150 people, and most days about 150 of them order the burger. So, okay, have we accomplished anything with respect to our environmental goals? Well, we're still improving, but we've done a life cycle analysis of our first product and compared it to the same product from a cow, and the greenhouse gas emissions are 1/8 the same emissions, the emissions in producing the burger from a cow. It uses 1/4 the water and 1/20 the land. Or put another way, if you buy our burger instead, a 1/4 pound burger from Impossible Foods instead of the same thing from a cow, you save the equivalent in greenhouse gases of driving 18 miles in a typical American car, taking a 10-minute shower, and you free up 75 square feet of land for a year for wildlife habitat. That's just 1/4 pound burger. Okay, so horses in 1800 were the core technology for the transportation system. And if you ask someone then what the future of transportation looked like, they'd probably say the horses will be faster. Well, it turns out they're not any faster. But in 1830, the world's first mechanized land transportation, which is this locomotive, raced against a horse and barely lost. But the headline of that story should have been, "It never lost again," because the horse is unimprovable. And once you switch technologies to a technology that's improvable in every dimension, it's no contest. And so today, mechanized transportation is still improving. We have, rovers driving on Mars. Try doing that with a horse. And again, the horse is no faster. I think we're in the same situation right now with respect to animal-derived foods as we were 200 years ago with animal-derived transportation. We have just begun, and we have our first product, which I would say, and again, decide for yourself, most chefs and consumers who tasted say it's running even with the same product from a cow. But the cow is not ever going to get any better, okay, at making meat. It's not that good at it to begin with, and it's not going to get any better. We are getting better every single day. And so I think that that's really going to be the future of meat and fish and dairy is not going to be animals, just as the future of transportation is not going to be animals. And that's all I have to say. I just want to thank this amazing, colorful group of scientists who have worked on this project and gotten us this far. And catch me at the coffee break with challenges and questions and so forth. I hope I've inflamed a few people here. Thanks a lot.
Thank you very much for that very inspiring and maybe also provocative statement. So now it's time for a coffee break. I suggest that we meet back here in 20 minutes, and there's coffee. Maybe there's even a hamburger for everybody. I don't know. Thank you.